All right, now we'll go to the beginning of Module 5 and start a lesson about arcs, central angles, and inscribed angles. And we are hitting part of 1 CCRSM standard C2, talking about inscribed angles, radii, chords, and specifically the relationship between central angles and inscribed angles. Let's get started. Lesson 4 starts off with some definitions, and I want to start here. First of all, an arc is part of the circumference. So for example, in my picture, I have a circle, and along this circumference, we have an arc, which is called arc AB, and it's written AB with an arc above it, not a segment, not just the two letters AB, which would be a length of a segment, but it's an AB with a little arc above it, okay? A minor and major arc are two different kinds of arcs. A minor arc is an arc that's less than 180 degrees, or less than a semicircle. For example, arc AB is a minor arc because based on this picture, if it was drawn to scale, it would be less than a semicircle. A major arc would then be an arc that is more than a semicircle. Okay, so the example of a major arc would be this arc right here. But we have a bit of a problem because I can't call that arc AB because I've already defined the minor arc to be arc AB. And so for a major arc, I have to use a third point when naming it. I'll call this point right here point C, and so a major arc will be called, I'll start at A, and I will go through C, and then I'll end at B. So a major arc is always named using 3 letters: a starting point, a point that it goes through, and an ending point. It doesn't matter if it's clockwise or counterclockwise. I just need 3 points. It starts at A, goes through C, and stops at B. A minor arc is always named with 2 points. An inscribed angle is where the 3 points that define that angle are all on the circle. So here's a picture over here, and angle ABC is an inscribed angle because most specifically B is on the circle, on the outside of the circle. Okay, and we usually see it where the other 2 points A and C are also on the circle. But the most important piece is that angle B right here is on the circle. It's an inscribed angle. A central angle, you might imagine that it has to do with center, which means that the vertex is on the center of the circle. For example, angle ADC is a central angle. Now, it's very possible, just so you know, for an angle not to be a central angle or an inscribed angle. So, for example, this angle right here is not either an inscribed angle or a central angle because this vertex is not on the circle or the center of the circle. So just be aware that there are other kinds of angles that we can have besides inscribed angles and central angles. The last definition is an intercepted arc of an angle, and that is the part of the semicircle or the arc that is on the interior of the angle. So for example, in this picture, either angle ABC or angle ADC both intercept the same arc, and that is arc AC, which appears to be a minor arc, so I will use 2 letters when naming it, and I'll call it arcs AC with an arc above it. Okay, I now want you to turn to the last page in lesson 4, or the blank page that's before lesson 5. All right, here we'll talk about angle and arc measures. The first thing to understand with a circle is that we can name angles that are inside the circle. This is a central angle because the vertex is on the center of the circle. And this angle looks to be roughly 80 degrees. Okay, the first thing to talk about is that we can also talk about the angles of arc. So this is arc AB. Then the measure of arc AB has a both a length, which we'll talk about in a future lesson, but also an angle. And the measure of arc B is the same as the central angle, which means that a full circle will have an angle measure of 360 degrees, which I'm hoping makes sense. Okay, now let's talk. The key, most important piece of this entire lesson has to do with inscribed angle. So let me draw one. I'll draw this one right here. So this angle right here, the vertex is on the circle, so this is an inscribed angle. And I'm hoping you see that the measure of the inscribed angle is not the same as the central angle. It looks smaller, okay? Specifically, it is half of the intercepted arc. So this intercepted arc, again, is the exact same as the central angle. This is 80 degrees. And this inscribed angle down here is half of 80, which is 40 degrees. Now let me also point out that's true for any inscribed angle that will intercept arc AB. So this arc right here, this angle is also 40 degrees because it intercepts an arc that has 80 degrees. Or this angle as well has an angle of 40 degrees because it also intercepts the arc of 80 degrees. Okay, so the most important piece of this entire lesson is that for an inscribed angle, it's equal to half of the intercepted arc. All right, I'm now on the exercises on page 32, and I'll go through some of these. Okay, first of all, in 1A, we are given that the measure of angle D is 25 degrees. Okay, this is an inscribed angle because the vertex is on the circle. Now I just learned that the inscribed angle is half of the arc. Okay, now that means that the arc will be double the inscribed angle. So this arc, I lost the letter B, C, must be 50 degrees, and X is a central angle, which is the same as the intercepted arc, and so X must also be 50 degrees. Okay, that's A. B says the measure of angle D is 15 degrees, and the way I'm going to approach this, I'm going to point out something else. Now we know that this would be 30 degrees, arc BC, but I'm asked to find this angle up here. Okay, now there's a lot of other things, tools that we learned earlier in the year that we'll have to use in this. Okay, one of which has to do with isosceles triangles. I will point out that AD is a radius of the circle, and AC is also a radius of the circle, which means that this right here is an isosceles triangle. And we learned earlier in the year that isosceles triangles have the same base angles. Remember that? So I've had isosceles triangle, they have the same base angles. And so that means that this angle right here, 15 degrees, and X would have the exact same measure because it's an isosceles triangle. So X must be 15 degrees. In letter D, we're told the measure of angle B is 32 degrees. And this is an inscribed angle because B is on the circle, which means this arc right here must be double 32, which is 64 degrees. And now I know that angle A right here is a central angle that'll have the exact same measure as the intercepted arc, which is 64 degrees. Now I'm still trying to figure out what x is equal to, but I remembered that this AD is a radius, and so is AC, which means this blue triangle right here is an isosceles triangle with x as a base angle. Well, I know these are the same, and I know that for a triangle, the angles add up to be 180 degrees. So I can subtract 64 from 180, and that's equal to 116. And now I have two angles, and so I can divide this by 2 and get 58. And so x is equal to 58 degrees. Okay? In letter E, we're told that BD is equal, where BD is here, is equal to AB. Okay? Now, what that also means, because AB is a radius, that this is also the same as AB, and this is the same as AB, and this is the same as AB. So what I have right here, this green triangle, is an equilateral triangle. And we learned earlier in the year that equilateral triangles are also equiangular, meaning they all have the same measure. And 180 degrees divided by 3 is 60 degrees. That means that x must be equal to 60 degrees. Okay, now to figure out what W is equal to, this is also 60 degrees because all three angles are the same and they're all 60. Now I will look right here at this straight line. Okay, which means that W plus 60 must equal 180. And now I'll combine like terms. 2W is plus 60 is equal to 180. I'll subtract 60 from both sides. And 2W is equal to 120. And dividing by 2, I find that W is equal to 60 degrees. All right, this video is about arcs, central angles, and inscribed angles. Thank you for watching.